Okay, next test will be the Unit 9 test. We are going to be working in the metric system. It's the same exact concepts of what you were just doing on that other test. I would argue it's easier. Okay. Here are your measurements. You got 1,000, and I put a table on each page. On the table you would need to do the conversion, so that's nice. You don't have that other table where you have to look back and forth and code it and all that. There's 1,000 millimeters to 1 meter. There's 100 centimeters to 1 meter. 10 decimeters to 1 meter. 1 meter is a meter, duh. There's 0.1 decameters to 1 meter. Another way you can write that is if you made that a full decameter by moving the decimal once to the end. That'd be 1 decameter. Move it once equals 10 meters. Move it twice to make one full hectometer. Move it twice, that would then be 100 meters. Decimal moves 3 times to make 1 full kilometer. If you move it 3 times here, that's 1,000 meters. So, but it's easier if we just go with this rather than make another table where I write that as 10 decameters, or 1 decameter is 10 meters, 1 hectometer is 100 meters. And 1 kilometer is 1,000 meters. So we have 23 meters as centimeters. So we're going to make that conversion. It's really the same as you did before. 23 meters over 1. We have meters, and we want to get centimeters. Okay, meters. So these are all in meters. You just got to find the centimeters. So it's 100 centimeters to 1 meter. So I put 100 with centimeters, 1 with meters. Get rid of your meters. And you're in like Flynn. You can just take 23 times 100 if you want to do the parentheses. Either 23 times 100 if there's only ones, or you can go 23 times 100, close parentheses, divided by 1 times 1. Okay, that's going to be 2,300. So 2,300 centimeters. 372.5 meters is kilometers. So you got 372.5 meters. You're going to put a 1. Meters in kilometers is what goes here. You got to have meters on bottom so that they can cancel, and then kilometers on top. Meters, kilometers. So 1 meter, 1 full meter is 0.001 kilometers. Again, you could also make that 1 full kilometer and write 1,000 meters, but we probably don't want to do that to convolute what we're trying to do. So if you have ones on the bottom, you can use them, but it's really just 372.5 times 0.001. You can hit divided by 1 times 1, but it's really 0.3725 kilometers. Kilometers is kind of most similar to miles. Centimeters would be most similar to inches. Meters would be most similar to yards. Okay, now the adding, you have 6.3 centimeters, adding 13.6 millimeters. You want to know how many millimeters that is. So what we do before, we want millimeters right there. So cross out the 6.3 centimeters, and that one I just crossed out, I'm going to put 6.3 cm over 1, and that was cm, and I want to get to millimeters, because I want to be able to write this in millimeters so that then I can just add 13.6 to it, okay? Okay, 10 millimeters, 1 centimeter. Okay. It's just 1 times 1 on bottom, so you can just take 6.3 times 10, and that's 63. Rewrite that as 63 millimeters. And now since they both have the same label, you can now add them. 63 plus 13.6 is going to be 76.6. Okay, same idea here. They want centimeters, so get rid of the one that's not centimeters. Go down here and convert it. 70 meters over 1. I had meters, I want centimeters, so meters, centimeters. So 100 centimeters to 1 meter. Get rid of the meter labels, and now 70 times 100 is 7,000. So you rewrite that then as 7,000 centimeters. 8,000 minus 7,000 is 1,000. That's all you do. You just take the one that's in the wrong unit, not in the one you want your answer, convert it, then do the adding or subtracting. Okay, express each metric area measured in indicated units. So now you can see the numbers are bigger. That's because 1,000 to the second power is 1,000,000. 100 to the second power is 10,000. 10 to the second power, so squared just raises it to the second power. Okay, it says 23.6 square millimeters as square meters. So again, 23.6 mm second over 1. We want mm second, millimeters squared, and meters squared. So here's my meters squared. I just find the millimeters squared. You can write 1,000,000 with your millimeters, or you can write 10 to the 6th power. It doesn't matter. If you don't want to write all those zeros, write 10 and then to the power of how many zeros. Get rid of those, then we're good to go. Okay, this is going to be a very small answer. So you got 23.6 times 1 divided by parentheses 1 times 1,000,000. Write that whole thing, okay? 0.0000236. 236 tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions, 10 millions, 236 10,000,000s, very tiny. Okay, 0.7 decimeters squared is millimeters squared. Okay, dm squared, mm squared. Okay, and that's where this comes from. If there's not a meters, I wrote down what you would need. So you got 10,000 mm squared. Again, you could also write that as 10 to the 4th power, and then 1, okay? 0.7 times 10,000, 7,000. 7,000, and get rid of the labels. You're left with millimeters squared, 7,000 mm squared. Now let's say I wrote that as 10 to the 4th. 0.7 times 10 to the 4th, same thing. Okay, so if you're not a fan of writing all those zeros, just write it as a base of 10. Okay, cubic. Don't look at that top table. Okay, just look down here at your cubic, because I wrote everything in terms of 1 meter, or the table did. We might need cubic millimeters and cubic centimeters if I wrote it. So you got 2,400 cubic millimeters. That's because it's to the 3rd. And then I have cubic millimeters, and I want it to end up at cubic centimeters. mm and cm, you're not going to find it on the table because that all needs a meter. So mm and cm, you got 1,000 mm, or 10 to the 3rd power, and 1 cm. Okay, so you got 2,400 times 1 divided by 1 times 1,000. Yes, I'm well aware you can just take 2,400 divided by 1,000. It's 2.4 cubic centimeters. Okay, 4 cubic meters is cubic centimeters. So 4 cubic meters over 1. You want a unit multiplier that has cubic meters and cubic centimeters. So cubic meters is on the first, goes to the bottom. Cubic centimeters to the top. Okay, there's all my cubic meters. Got to find the cubic centimeters. There's cm to the 3rd. That's 1,000,000. You can write 1,000,000, but if you don't have enough space, write 10 to the 6th power over 1. Okay. You can write 1,000,000. It's fine. It's just a way of shortening the process. 4 times 10 to the power 6. If I have 1s on the bottom, I'm not going to divide. That's 4,000,000. Okay, so there's 4,000,000 cubic centimeters within 4 cubic meters. Okay, measure each metric capacity unit. 2,100 milliliters as liters. So we got the 2,100 milliliters to 1. And I want it in liters, so I need milliliters and liters, ml and L. So ml and L. Well, there's ml and L, so you got 1,000 milliliters, 1 liter. Remember, put these numbers next to their appropriate labels. cross it out. So it's 2,100 divided by 1,000. I got 2.1. So it's 2.1 liters. Okay, 5,210 cubic centimeters as liters. Okay. 5,210 cubic centimeters over 1. So we're going to have cm to the third and L, cm to the third. That means cubic centimeters go here, liters to the top. So obviously I need liters and cubic centimeters. Well, there's cubic centimeters, and that's milliliters, so that won't work. There's cubic centimeters, aha, that's liters, okay? cm third and L. So 1 is with the liters, 1,000 is with the cubic centimeters. Please include the labels, okay? There's a couple of you have told repeatedly to put, you don't understand it because you don't put the labels, okay? So then you know where to put them. So 5,210 divided by 1,000, you can do the little parentheses. This is a 5.21, so 5.21 liters. I'm going kind of fast because it should be, how to do it is the same way. Okay, unit of weight, 730 milligrams is grams. So you put your 730 mg over 1, and then mg, and then we want it in grams. So there's G, there's mg, okay? So 1,000 goes with milligrams. So again, some of you guys that put the 1,000 to 1 backwards is because you're probably not labeling, okay? Cross those out. And then you take 730 times 1, close parentheses, divided by 1 times 1,000, 0.73 grams. Okay, 2.7 metric tons is kilograms. So 2.7 metric tons over 1. And you want metric tons in kilograms. So metric tons has to go to the bottom because I want that out, and then kilograms to the top. Okay, there's kilograms, that's grams. There's kilograms again right there, kg and metric ton right there. Okay, so 1 metric ton is 1,000 kilograms. Remember, kilograms would be like pounds. Okay, most similar. Actually, in the real world, 1 pound is 2.2 kilo, is equivalent to 2.2 kilos. Okay. So, get rid of those. Or my bad, that's wrong. 1 kilogram is 2.2 pounds. I misspoke. Okay. So a lot of times if you're lifting weights, if they're measured in kilograms, okay, if you see like 150 kilograms, that's actually 330 pounds, okay? So if you see them labeling kilo, don't load the weight up thinking it's the same as pounds, it's more, okay? Okay, so 2.7 times 1,000 is 2,700 kilograms. Okay, now you're converting compound unit measurements. Okay, that's when you put the 1, and instead of putting 12 meters over just an empty 1, you put 1 second, because you got, first off, you need meters and kilometers. Okay, meters is here, and then kilometers here. These labels I'm circling need to be on this second unit multiplier. Then I look at the next unit, seconds and minutes. Those aren't the same either, so I need seconds and minutes here. Since minutes is on top here, okay, or my bad. Since seconds is on top right there, seconds would go on top here, or on bottom here, it goes to the top, and then minutes. So again, you don't have any common units, so this is for getting the meters to the kilometers. Meters is on top, meters on bottom, kilometers on top. And the second unit multiplier includes seconds and minutes. I look at my ratio, seconds on bottom, so seconds goes to the top. Then I will be able to cross out the seconds labels and the meters labels. Okay, so kilometers and meters. Okay, right there, 1 meter, 0.001 kilometers. Seconds and minutes, there's 60 seconds to a minute. Now get rid of your labels where they belong. The meters go bye-bye, the kilometers don't, okay? There's no kilometer units on the bottom. Seconds, bye-bye. Okay, so really it just becomes a multiplication problem. 12 times 0.001 times 60, 0.72, okay? 0.72, to label that, you put km, but then you underline it and put minutes, because you have converted it to kilometers per minute. Another thing, M stands for meters, okay? It doesn't stand for minutes. Minutes is MIN. We've had those before. Just put a 1, I'll repeat that. 12 meters, 1 second, meters in kilometers. Remember, meters have to go diagonal, okay? Kilometers. And then these weren't the same either, so I need seconds and minutes on here. Seconds, go here, and then minutes right there. Okay, now the next table might look kind of weird. It's actually the same process. Okay, these are prefixes used for language and small values. Okay. Tera means a trillion. The word giga means a billion. Mega, 1 million. Kilos, 1,000. And those are the powers. As I said, you can count the zeros because rather than write a trillion, there's 12 zeros. So 10 to the 12th, 10 ninth. And I will be using the powers of 10. I'm not going to be writing all the zeros. Okay. Milli means it's less than a full 1, okay? It means it's 0.001, 10 to the negative third, it's smaller than a whole. Micro means it's smaller than a whole by 10 to the negative 6. So these are bigger than 1 whole, these are smaller. Okay, so anyway, with that established, now I need to convert 4.9 times 10 to the 5th hertz to megahertz. Put the 4.9 times 10 to the 5th over 1 hertz times, and I'm going to write hertz and mega, okay? You don't need to write megahertz, just write the prefix. Hertz, mega. Go look up mega. There's mega, 10 to the 6th power. And then 1 goes right there. So I can cross out the hertz and it just becomes a multiplication problem. So I take 4.9 times 10 to the power of 5 times 10 to the power of 6. Use the caret button and we get 4.9 times 10 to the 11th power. You write it as scientific. And that makes sense because when you're multiplying numbers in scientific notation, you have that and then you add the powers. Okay, 63 times 10 to the negative 11th farads is picofarads. I'm maybe mispronouncing that. Okay, so again, same idea. 63 times 10 to the negative 11th over 1. Label that farads. Then I put farads here. And then the prefix pico. I should underline pico. Here I underline mega, so that's what you want. Here I should have underlined pico for you. So let's look up pico. There it is, 10 to the negative 12th power. And then 1. So I can get rid of the farad labels, and now I just have pico. So I take 63 times 10 to the negative 11th power, and then times 10 to the power of negative 12. 6.3 times 10 to the power of negative 22. Boom. Story problems are actually a lot easier than the last one. Okay. You don't need a table for this car traveling problem, okay? It says a car travels from town A to town C by the way of town B. The car travels 175 kilometers. The trip takes 2.5 hours when you go from A to C. By way of town B means you go through town B to get from A to C. Now, it takes 0.75 hours, i.e. 3/4 of an hour, to get from town A to town B. assuming the same speed is maintained for the entire trip, how many kilometers? I don't need to make any conversions here, okay? Remember, kilometers are most similar to miles. I didn't say exactly like them, but so I'm A, B, C, okay? Now, mark the distance A to C. It takes 175 miles dash, and it also takes 2.5 hours to get there. Now, from A to B, it takes 0.75 hours. And I'm trying to, or not miles, get rid of the miles, it's kilometers, okay, kilometers. And I'm trying to figure out question mark kilometers. Well, all you're going to do is set up a proportion. These aren't unit multipliers. You're going to put hours, so you can do the cross multiply and divide, okay? And then kilometers. So look at your hours. You know you got 2.5 and 0.75. Remember, set up the common labels. Okay, then your kilometers. Well, you know you got 175. That's with the 2.5. And then X kilometers. You're trying to figure out how many kilometers go with the 0.75. And then you can just cross multiply and divide. 0.75 times 175 divided by 2.5 is 52.5. So 52.5 kilometers. Again, really, you can just set up a equals. Get the equals. It's not multiplication, though. Equals. You put the hours together. Remember, 175 is with the 2.5, and then X I wouldn't know. It's a proportion. 17, determine the total length in meters of the wall section. Really, it's just adding. First, find the ones that are actually meters. You got decimeters, centimeters, decimeters, centimeters, there's meters, okay? Right, 6.3 meters, cross it off. I would do the decimeters next, the DMs, right there, not there. That's centimeters, right there. That's centimeters, and right there. Add those up. They're all common. So it was 10.2 plus 4.52 plus 8.3 plus 4.52, and that gives me 27.54 decimeters. Okay, then the cross all those out then after you've added them, cross them out. Then the centimeters, you add 10.4, 10.4. That's going to be 20.8. Okay, now we need this all in meters, okay? So we need to make, I'm going to make a little separation. We're going to make two conversions. First, we're going to put our 27.54, and again, we want to convert those two things. We want to get them both in meters, so they're all the same, because it says they want the answer in meters. And then we'll add them, okay? So I take that 27.54 dm over 1, and I want meters. So it goes dm meters. Okay, so 1 meter is 10 dm, so 10, 1, cross them out. And then you can take 27.54 times 1 divided by 1 times 10. 2.754, you can go put that right there. Okay, now we have to take the centimeters, 20.8, and get those to meters. So centimeters, meters. Meters, centimeters, 1 to 100. Cross out centimeters, and you have 20.8 times 1 divided by 1 times 1,000, 0.0208. Okay, add them and you got your answer. 6.3 plus 2.754 plus 0.0208, 9.0748. That would be how many meters that is. So again, you just add the common units, the ones that are not in meters, in M. Okay, you make the conversion. You're going to have to do two of them. There's another problem later just like that one. Actually, a couple. Like this one, except you're on this table here. An assembly consists of 5 metal plates. The respective areas of the plates are 450 square centimeters, 550 square centimeters, 10.6 square decimeters, 14.5 square decimeters, 0.2 square meters. Determine the total surface measure in square meters. So first I look at my square meters, just like here, except there's not a picture right there. That's the only one I got. Now, now do your square decimeters, okay? Right there and right there. I add those, it's going to be 25.1, adding them, okay? Plussing them. Then I'll do my square centimeters. 450 plus 550 is going to be 1,000. Then what do you do from there? The exact same thing, except you're looking at a different table. You want these both converted to M to the second. Okay, so I had 25.1 square decimeters, dm to the second power over 1. And then dm to the second and m to the second. So m to the second, there's dm, so you got 100 to 1. Cross those out. So I'll be taking 25.1 times 1 divided by 1 times 100, 0.251. Okay, now here I will be taking my 1,000 square centimeters, and I want it in square meters. Everything I want in square meters. M to the second. Please put the labels. 1 m to the second, cm to the second, that's 10,000. And then the cm's go away, so it ends up being essentially 1,000 divided by 10,000. 0.1. Add them up and you have your square meters, just like the last problem, except it's a different table. Add your m's, your cm's, your dm's. 0.2 plus 0.251 plus 0.1, 0.551. So essentially 18 and 17 are the same problem. Again, 16, if you don't want to draw that picture, if you just want to make your proportions out, remember, out with a proportions, not like a multiplier, okay? That the labels have to be lined up the same. Okay, number 19. Had one like this on the last test. A roll of fabric has a surface measure of 5 square meters. How many pieces, each requiring 2,500 centimeters of fabric, can be cut from the roll? Make an allowance of 10% per waste. Now, we want everything in meters, so we have 5 meters to start with, and we will be dividing by, to divide I need to get another number of square meters here, okay? So I need to convert that 2,500 square centimeters to square meters. Okay, so I know how to do that. I take 2,500 square centimeters over 1, and I want it in square meters. So here's square meters, meters to the second, centimeters to the second, be 10,000. Again, you can also write that, so 1 to 10,000. Again, you can also write that as 10 to the 4th. Now, there's one thing you got to remember. This is me figuring out every piece, but every time I cut a piece, 10% also has to come off for waste. So at the end, you're going to multiply this by 1.10, because the 1 represents the piece itself, and then another additional 10%. So you got to remember the waste, 1.10. If it's 15, it's 1.15. So after I do my little math here, I have to remember to multiply it by 1.10. Okay, I got that. Now times 1.10. 0.275. And now I know what to divide by. So it's a division problem. You take your square meters you have. Since it's giving me the pieces in square centimeters, I go ahead and convert them, okay, into meters. But then remember to multiply by that percent waste, okay? It means 1.10. So 5 divided by 0.275, and I got 18. You can only cut off full pieces, so you'd have stuff left over at the end. 18 pieces. Okay, it's similar to the last one, except the last one, there was a problem on the last test like that, except you didn't have the percent waste. So after you get done with that, and you get how many square meters are a piece, you got to take that times 1.10. Okay, then the last one's an easy one. The liquid intake of a hospital patient during a specific period of time is as follows. You got 300 milliliters, 100 milliliters, 150 milliliters, 170, and you can see them all. What's the total liter intake of liquid for the entire period? Does it look to you like I have any liters? Liters is just L. No, they're all mLs. So I just add them all together because they're all the same. Add them. Okay. And I got 1,365 milliliters. Now you just have to convert those to liters, okay? So 1,365 ml over 1. So I have my milliliters, I want liters. Well, 1,000 milliliters to 1 liter. So it really essentially ends up as 1,365 divided by 1,000. 136.5. I don't know, I didn't do that right. That doesn't make any sense. 1.365 liters, okay. So essentially 3 of the 5 problems, you're just adding the units and then just converting them, okay.